Hello everyone, welcome to our project simulation result and simulation presentation. Today I will talk about our project. My teammate, I'm Enes Erdoğan, my teammate is Fatih, Mehmet, Ayhan. Our project is switchable counter and variable pulse generator. For the pulse generator we are use of the established multi-repeater circuit, and in here you can see the two pies of the established multi-repeater circuit. The first one is the 1 Hz established multi-repeater circuit. Other one is the 2 Hz established multi-repeater circuit. To invert the signal we are use of the CMOS circuit, and the other one project task 2x2 MUX circuit, multiplexer circuit. For this we are use of the 2 pies of the 2x1 MUX circuit. I want to show our simulation results. Okay. In here you can see the 2 Hz signal graph. To clear, I will show here at yes, you can see it too clearly here. The maximum voltage is a 5 voltage here, and you can see the here clearly. I want to explain how is the working established multi-repeater circuit. Okay, for the established multi-repeater circuits contain the 2 NMOS and 2 capacitor and 4 resistor basically. In here actually capacitor charged and NMOS activate, and we are see the 5 voltage and the other capacitor charged, and the capacitor is not active because of this capacitor discharged and other capacitor charged. In VRC the pulse signal. In here you can see how is decide to 1 Hz and 2 Hz. We are decide with the resistor to actual according to formula. Okay. In here you can see the MUX circuit CMOS level. For the MUX circuit we are use of the 4 PMOS and we are use of the NMOS here. And I will show again the simulation results. In here you can see the 2 Hz signal, and switch is activated. You can see the 5 Hz, and in here you can see the B1 signal. In here which started the 1 Hz. After the its switch is activated you can see the 2 Hz signal. In the project report you can see the truth table, and you can see the more detailed explanation. Okay, I will show our other one to simulation. In here for in project task 1 to counter circuit. For the counter circuit we are use of the D flip-flop, and this is a gate level D flip-flop circuit, and we are use of the package form. You can see the here, yeah. We are use of the for 1 digits we are use of the 4D flip-flop. This working on a 16-bit, but we are limited with the gate. I will show other one in the Proteus. First, I want to show this simulation result. Basically, 1 minute. Yeah, you can see, and you can see here, and you can see other way, and we can see, and we are see the pulse. The flop you see the half of the frequency actually. Okay, I will continue the Proteus because of the spice simulation not contained any encoder and the display. Because we want to see is the clearly to counting working principle. For this way, we are use of the Proteus because of the Proteus interface is the user friendly, and you can see the moreover the component according to spice simulation, but it's have a half of some of the disadvantage. For example, oscilloscope as result and graph. It's not clearly here. Spice simulation better than the Proteus for the graph. Okay, I wanna start the simulation, and you are see the counting, and I will explain how it's working actually. In here, coming to our pulse signal is the clock, and you can see the for D flop. It's, I will say again, it's a 16-bit. We are limited this signal with the AND gate and inverter. We are limited because the digits I will see to decimal format, and you can see here go to 0, 1, 2, 3 and 49. In here these flop working 10 bits, and these are working on 10 bits. This is the other 7 segments display, and for here we are use of the encoder, the flop signal coming here and encoding the encoder encoding the signal and sending the display, and we are see the sum of the counting number. And you know, encoder less significant bit, it's the coming here is deactivate here, it's not coming to 1 bit, and it's less significant bit is the changed with the 2 bit. And I will see the 2 counting here. Yeah, you can see the 2 counting. It's counting 2 2 2 clearly. In here, counting whenever we see this 9 here, it's counting 1. It's counting 1, and you can see the other digits. The other way in the project task want to duty cycle. For the duty cycle, we are use of the NAV 555. You can see clearly graph here, and this pulse signal 1 Hz actually, and these are connected to MUX circuit, and we can see the we can decide the 2 Hz or 1 Hz duty cycle. I will show how it's working. In here actually potentiometer, multi-spice simulation not contain the potentiometer. In this way we are use of the we are simulate of the potentiometer in here, and you can see 2 legs here, RX and RE. Okay, I will show them more for resistor. Okay, I will say the 80, and in here, you know, our potentiometer 100 kilo and 20 key. Yeah, I will start simulation again. You can see the duty cycle is changed. Duty cycle is increased, and we are changing this. Okay, I will show other way. It's 10 key, it's 90 key. Yeah, you can see the again simulation is changed. Our duty cycle change it with the 0 at 100. Project task 1 to 0 and 50. I will explain to how is working this one. This one working on pulse signal coming to reset pin and VCC pin, and with the 47 key, it's capacitor charging it here disactive, it's activate, it's working on the duty cycle. The most significant part is the here diodes and the capacitor. This capacitor is not important. This capacitor for the working on clearly. Yeah. If you want more information, you can look at our project task. You can see more information and more graph here. Thank you for listening to me. Have a nice day. Goodbye.